Well, good morning, Advanced Chemistry. This is Mrs. Sharp here with you in spirit this fine Monday morning to talk to you about our last two concentration expressions, parts per million and mole fraction. So without further ado, here we go. Parts per million. The definition of parts per million is exactly what it sounds like. We abbreviate parts per million PPM. And parts per million is defined as the number of solute particles per 1 million particles of total solution. So it's like a percent, except for instead of per 100, mass per 100 grams of total solution, it's particles per 1 million total solution. So this is really, really easy. You can set it up as a proportion. If you have percent by mass, remember, is grams of solute over grams of total solution. Times 100. If we get a percent, and let's say this comes out to be, 25% by mass, that means that for every 25 solute particles, or 25, the mass of solute particles, you would have 100 as your mass of your total solution, or 100 particles of your total solution. So you could find out easily what that would be out of 1 million. And just set up a simple proportion. So to get from 100 to a million, you have to obviously multiply that by 10,000. So you're going to multiply 25 by 10,000. If you multiply 25 by 10,000, you would get 250,000. So the proportion is the same, but these are not usually used for things like a 25% solution. They're used for things that are really, really, really dilute and very small. So if I had something on the order of 1 part per million, that's like 32 seconds out of a year. That's the order we're talking about here. Very, very small. So used for extremely small concentrations. So something like a 25% by mass would not be appropriate for parts per million. But those two are related to each other because of, instead of percent, which means per 100, we've got per 1 million. There are actually even parts per billion. We're not going to get into that, but some things are so tiny that even parts per million don't work. We need a parts per billion. So let's look at one of these here. Here's an example. Whoops. It says, according to a lab procedure, you dissolve 0.5 grams of sodium chloride into 500 milliliters of water. How many parts per million is this solution? So I would go ahead and set this up as a percent by mass first. So if I'm doing a percent, I've got 0.5 grams. And total mass of my solution is going to be that 0.5 grams plus my 500 milliliters of water. Because water is 1 gram per milliliter, that's also going to be 500 grams. So I'm going to have 0.5 plus 500 grams of my solvent times 100. So my percent, 0.5 divided by 500.5 times 100. My percent is 0.0999, or 0.00999 parts per 100, which is how many parts per 1 million. Remember, we're multiplying this by 10,000, so we need to multiply this by 10,000. So 0.0999 times 10,000 is equal to 999 parts per million. So the key to this is deciding what percent. This should be, remember, parts per million is more appropriate for things that are very small. So it's probably going to be a very small percent, and then multiplying that by 10,000 to get parts per million. So parts per million and percent are related to each other very closely. So let's talk about mole fraction now. Here is the definition of the mole fraction. The mole fraction is expressed by this Greek letter chi, which sort of looks like an X, and we have an A next to it, which represents the solute. So the mole fraction of A is going to be equal to N of A, which is the moles of A, which is the solute, and that's going to be over the sum total of moles of A plus moles of B, which is the solvent. So basically, the mole fraction of A which is the mole fraction of the solute, is the number of moles of A divided by the total number of moles of solute plus solvent. You could do a mole fraction for your solvent if you wanted to. You just put the number of moles of B on the top, and it would still be total number of moles of A plus B on the bottom. It's just that normally we don't care about the mole fraction of the solvent. We care about the mole fraction of the solute, just like we care about the molarity of the solute and the molality of the solute and the percent by mass of the solute, not the solvent. If you take the mole fraction of A and the mole fraction of B, those should add up to equal 1 exactly. Infinite number of sig figs. So those two together should equal 1, which is handy because I can easily figure out then one or the other based on this relationship. So this is truly your definition right here. You need to know the number of moles of A and the number of moles of B, and we can figure out our mole fraction. So let's do it. Here's an example. Suppose you have 36 grams of hydrochloric acid that you dissolve in 100 grams of total solution. It's a question. What is the mole fraction of this solution? Okay, so remember, I'm going to write the definition of mole fraction up here. The mole fraction of the solute is going to be moles of solute divided by moles of solute plus moles of solvent. So I'm going to need to figure out two things really, and that's the number of moles of solute and solvent. Well, our solute is hydrochloric acid, and it's 36 grams. So let's go ahead and convert that to moles. So moles of A, my solute, is equal to 36 grams, whoops, double decimal, of hydrochloric acid. And in hydrochloric acid, let's see, chlorine is 35.45, hydrogen is 1.01, so that should be 36.46 grams per 1 mole. 36.46. And 36 divided by 36.46 is going to be 0.987 moles of A. So my Na is 0.987. And on the bottom it's 0.987. And my number of moles of B, which is my water, my solvent, is going to be, I've got 100 grams total solution, so my number of grams is going to be 100 grams minus my 36 grams to start. So that's of my water. So 100 minus 36 is 64. And in water, 1 mole is equal to 18.02 grams. So moles of water is 64 divided by 18.02. And that is 3.55 moles. So that's my moles of B. So I've got 0.987 for my moles of A, and then I need to add on the bottom my moles of B. So now I should be able to do 0.987 divided by 0.987 plus 3.55. That's my total moles, and that comes out to be 4.537. And 0.987 divided by 4.537 is equal to 0.21. And I guess my third sig fig is going to be a 5. And that is a unitless number, because we got moles on the top, moles on the bottom, so moles divided by moles would cancel, so that's a unitless number, 0.215. So that's my mole fraction of A, which means by default, since mole fraction of A plus mole fraction of B equals 1, my mole fraction of B is just going to be 1 minus this 1 minus 0.215. So my mole fraction of B automatically is 0.785. And you could go through and you could plug in 0.355 divided by all this. You should get the same answer. Because of this relationship, we know it's 0.785. So 0.785 mole percent, mole fraction, is going to be my solvent. 0.215 is my mole fraction of my solute. So I want to show you the relationship to some of these other things. So our mole fraction's relationship to percent by mass and molality. So we've got a certain solution that has a mole fraction of 0.325. Now that is going to be my solute. If you're given something that is a solution, that mole fraction you're given is going to be of your solute. So your mole fraction of your solute is 0.325. So remember, that means really 0.325 moles of solution per, or excuse me, 0.325 moles of solute per 1 mole of solution, which is represented by 0.325 moles of A, and then whatever is left over of B, which would be 1 minus 0.325, which would be 0.675. Okay? So that's just coming from saying you've got your mole fraction of 0.325 moles of A per 1 mole of total solution. So if we're going to have 1 mole of total solution, 0.325 of that is A, the rest has to be B. So that's where that came from. Okay, so it asks what is the percent by mass. So what I need for percent by mass is grams of A divided by grams of A plus grams of B. So what I really need to do is convert both A and B to grams. So my number of grams of A is my 0.325 moles of A, and A is hydrobromic acid, which is HBr. So in 1 mole of HBr, I have, oh shoot, what's Br? Br is 79.9 plus my hydrogen, of course. That's going to give me 80.91 grams. So times 0.325 is 296 grams. And my number of grams of B is going to be just this 0.675 moles. And the molar mass of B, well, it's a solution, so the solvent is water, because water is the universal solvent. So if it doesn't say something else, it's water. It's aqueous. And 1 mole of water is 18.02 grams, and 0.675 times 18.02 is going to give me 12.164 grams. So before, the mole ratio of A was much smaller than of B, but because of the molar mass, we actually have more grams of A than of water. So now we're just going to plug these values in. So we should have 26.296 grams of A divided by our 26.296 plus 12.164 grams of B. And of course, I forgot to say we're going to multiply by 100. So this is getting messy. I'm going to clean it up a little bit. And I just lost everything that I just had. So you are going to have to plug that in. I'm so sorry. Or Mr. Lewis can go back and you can plug it in because I just lost everything on there. I'm so sorry. I think that I had 12.164 for my mass of B. And let's see. 0.325 times 80.91. 26.296. Yeah, that's right. Okay, back in business. Sorry about that. And of course, got to multiply that by 100. So this is my percent by mass. Here's A, here's A, here's B. We just converted both of those moles to grams. It's just tedious. So 26.296 plus 12.164 is 38.46 on the bottom. So 26.296 divided by 38.46 is going to give me, times 100, is going to give me 68.37% by mass. Whew! All right, so let's look at one final thing. I think this will help. Relationships. Because really, you just have to do a lot of these before you're going to feel comfortable going back and forth. So the definitions themselves, I think, are really easy. It just is a matter of being able to be comfortable converting back and forth. So what I'm going to use as the middle here is percent by mass. Because if you know percent by mass, you can find a lot of other things. For example, you can find mole fraction. You can go back and forth between mole fraction and percent by mass. So I'm going to make a double-sided arrow. And if you know percent by mass, you can go back and forth between molality and percent by mass. We've done some of that. And then actually, you can go back and forth between molality and mole fraction if you want to. So this is like a big circle. You can go back and forth through all of these. Let's just look at this really quickly here. If you want to go from percent by mass to mole fraction, we just talked about that. We just have to convert between moles and grams of both our solute and our solvent. So it's a pain, but you can do that. If you wanted to go from percent by mass to molality, all you would have to do is to convert between moles and grams of your solute, because molality is moles of solute divided by your kilograms of solvent. So by percent by mass, you should already be able to figure out the mass of your solvent. So you don't have to do any converting, you just have to figure out what it is. But you just have to convert your top part from the grams in the mass to the moles of the molality, or vice versa. Here you have to do by both, because this is grams over grams, this is moles over moles. Here you just have to do it for your solute. And the beautiful thing down here is that if you want to go from mole fraction to molality, you can as well. Mole fraction, you have the moles of everything, so you would just have to convert your moles of your solute, or excuse me, moles of your solute to grams of your solvent in this case, or vice versa. So here you're having moles divided by moles of everything. Here you're having grams divided by grams of everything. And here you're having just moles of solute divided by kilograms of solvent. So this is just, I think, kind of an easy way to visualize it. You can go back and forth between these. It's just a matter of maybe you would want to put the definitions of each of these things next to them and practice going back and forth, because like I said, figuring out percent by mass given the information is easy, but having them to convert is where it gets difficult. And then one more thing we can actually put on here is that from percent by mass we can go to parts per million, back and forth. And then if we know parts per million, we can figure out parts per mass and everything else. So I just thought that was interesting. Maybe that graphic will help you as you're converting. What I would like for you to do today is to add on to your assignment, your book assignment from last time. If you need to borrow books from the bookshelf, you may. This is what it was last time. This is what you were working on. I will have the book out for you to check those practice problems. I want you to add on to that assignment page 508, 83 through 85, so continue. These are all mole fractions. 83 through 85 are all mole fractions. And then I want you to go back and those same problems, I want you to take all those mole fractions and I want you to turn them into parts per million. And then I want you to take and turn them all into molalities. So using that graphic that we just talked about, you're going to go from mole fraction to parts per million. And you're going to go from either parts per million or mole fraction to molality. And remember, the key in there is don't forget your percent by mass is going to help you, or can help you do both of those. So give it a try. There's no answers for those ones, but we'll talk about it tomorrow. So best of luck, work hard, and I will see you tomorrow. Looking forward to it. Have a good day.